first simple machine we are going to learn about is the lever. A lever has three things you need for measurements. The fulcrum, which is also known as a pivot point, the effort force, right here being applied by the farmer, and the resistance, which in this case happens to be a rock that's being moved. There are three classes of levers. The first class lever, the fulcrum, is in between the effort and the resistance force. So here would be my fulcrum. Here's another example, and then also another. Alright, so in this picture you can see, this picture right here, you can see that the distance to the effort is twice as far as the distance is to the load, or also known as my resistance. So the effort force would be half of that of the resistance force. Right? Which is why it's easier for me to move that rock or whatever it is that's being moved. Right? And this is known as a mechanical advantage of 2. So now you've seen how manipulating distance using simple machines helps to make work easier to perform. So let's go see what we can find in the garage. Come on. Alright, look, I've already got some levers laid out for you that we're going to look at. Alright, I'm going to start with the first class lever. Alright, so we've got 2 forces and the fulcrum that we have to look at for each lever. Fulcrum is going to be where it pivots, okay, that pivot point. Your effort force, which is where I'm going to be putting the effort into it. And the resistance force, which we're going to be looking at the distance here to where, like, maybe the nail or whatever you're trying to pry out. Okay. So let's go ahead and measure what this is going to be. So I'm going to say my fulcrum is going to be right here where it's going to pivot. And I think I would have my hand about right here. So the distance is going to be 26 inches. Right? And then in that case, I would go ahead and make a mark there if I was going to be able to measure that force as well. But we're going to do the actual force on another example. Okay. So that's going to be where my effort is. So the distance effort, or in, because that's what I'm putting in, is going to be 26 inches. Alright, we also need the distance resistance. Alright, so the resistance is going to be right here, assuming I'm going to be using a nail. Okay, so wherever the resistance is, the center point of that. And here is my fulcrum again, right in the middle. So I'm going to measure that distance, and it is 3 inches. I'm not using a precision scale, so for this particular example, I'm rounding it to just the whole numbers. When I use something more of a precision, I can actually go out to more decimal points. In this example, I only have distances, so I'm going to find the ideal mechanical advantage. I'm going to use this equation right here. So that means then that IMA equals the distance of my effort divided by the distance of my resistance. So I'm going to fill those in with my values. So that means that 26 inches is my distance of my effort, and then the distance of my resistance was 3 inches. If I plug that into my calculator, I'm going to get something like 8.666, and it keeps repeating on. But if I'm going to look at the number of correct significant figures, I notice that my 3 here, it only has 1 significant figure, and then 26 has 2 significant figures. So my answer can only have 1 significant figure. So that means that my IMA for this nail bar is 9. Notice I don't have any units on this because my inches are going to cancel